We talked about data prep, and this week we're going to talk about two of the phases of the life cycle, and that's going to be phase 3 and 4. Phase 3 is model planning, and phase 4 is model building. They're very closely related, but you think of it as phase 3 is sort of the test phase, where we're going to go through and we're going to plan out a model and we'll test it out, and it may not be quite right, so we'll change it and we'll adjust it, or we'll come up with a completely different strategy. That's all in the planning phase. And it's really just kind of getting ready to go to phase 4, which is where we actually build the model that we've decided to use. So an overview of model planning and building, we're going to identify candidate models to apply to the data for either clustering or classifying or finding relationships in the data. It just depends on the goal of the project. What is it that your stakeholder is trying to get to? So part of the model planning phase is just to really get a clear understanding of what are we trying to get out of this, and then what data mining or data processing strategy should we use. We'll assess the structure of the data sets. How can they be analyzed? What data do we have? Are we looking at trying to predict a continuous numerical variable, which would be linear regression, or are we looking at trying to predict whether or not a customer is going to do A or B, which would be logistic regression? So what does the data provide us, and that's going to drive us as far as determining what model we might want to use. We'll ensure that the analytics techniques enable the team to meet the business objectives or accept or reject the hypotheses. Again, that's just making sure that the data that we get and the model that we choose or the strategy that we choose is going to help us get to the eventual goal. Should the analysis use one model, or should it use a combination of models? For example, association rules and linear regression. Both are needed if both are needed to test out the hypothesis. You may find yourself in a position like we were with the Charles Book Club. There was K&N classification and logistic regression. Many of you use both of them, and so there could be a situation where in order to get to a good result, or in order to be able to actually take full advantage of the data set, there's more than one model that we want to build. And then we might also want to look out at the internet and say, what have other analysts been able to find? There's a ton of resources out there, and there's a ton of forums out there that you can use where you can learn from the experience of others, and that may give you some tips on what you want to build into your model. So data exploration and variable selection. So up until now, the data that the work we've done with the data sets have really focused on cleaning them up and making sure that they're solid and consistent, and that what's in there isn't outliers or it's not crappy data or anything like that. It's really focused on data hygiene. Now we're going to look at the relationships, the real relationships. Now that we've cleaned everything up, we're going to look at the real relationships. And the best example I could come up with this, or for this one, is when we did the multiple linear regression models in the data mining class. We did this very work. We went through and we looked at correlation tables to try to identify variables that had a reasonable amount of relationship that we could use, that we could take advantage of. And so that's really what we're doing in this next phase, is what have we been able to find out about our data. So the focus is on identifying useful relationships. What did the data show? What does the stakeholder suspect? And what do the hypotheses expect in certain comparisons? And so really we're getting at what might be the best predictors, or what might yield the strongest model. And again, it's just looking at our relationships and looking at what we have. Then we choose, now that we understand kind of the relationships of the variables in the data, what model is going to get us what we want. So we'll choose an analytic technique, or we'll choose a short list of techniques based on the end goal of the project. And we could figure out, so what are we trying to do here? Are we trying to predict a continuous numeric variable? Then we might use linear regression. Are we trying to predict the likelihood of an outcome? We would use logistic regression. Or trying to classify unknown data, then we can use a K&N or Bayesian classification. Or if we're trying to identify groups with common behavior patterns, we can use K-means or agglomerative clustering. And the list goes on. As you know, there are multiple strategies, but that just gives you kind of an idea is what is it we're trying to do here, and also the reason why it's important to sort of just select your model after you've looked at your data. If we're trying to do something like predict a continuous numerical value, do we have the relationships we need for that? Do we have, maybe 2 or 3 variables in our training data set that are closely related to the variable of interest, our output variable? And if we do, then we might be set up well. If not, we might not want to use multiple variable linear regression to try to address this problem. There may be another strategy that we want to use. So understanding the relationships in the data and the different models that are available to us will guide us in deciding what we want to do. Okay, selection of the tools for model planning. Before the development of the models for production, we want to build and test mini models. Okay, so now we've got an idea of the data and we've got an idea of the different models, and we've actually got one or two that we might want to select. Let's test them out. Okay, so let's figure out what we want to use. So we'll test mini models. By mini models, let's say it's the same model, but it can be done on a miniature set or a sample of the data. And we want to verify performance of the model on training, validation, and even test data before we're ever going to try to apply it at a higher level or on a larger set. So some of the good tools for use with mini models, either in the construction or the application, are things like R, like you've already used. SAS is a great tool to use, as also SQL Analysis Services is also a recommended tool. There are many other tools, but these are easily accessible and meet the needs for planning and testing. So you can use these tools to build your model, test it, and refine it, and to get to a point where you've actually got a lot of confidence in it because you've been able to sort of lower or reduce the error. Next, we're going to move on to building the real model. So this has been, and we've gone through planning the model. We've looked at the data. We've looked at the analytics techniques that are available to us. We've even built some mini models and tested it out. We've got to a place where we've reduced the error. Now it's time to scale it up, and we're going to actually build a model that could be either on a full data set or even a production data set. We're ready to go ahead and apply this to a production data set. The real model must appear valid and accurate on test data. It's got to give results that make sense relative to the business problem. It's got to satisfy the stakeholders' needs. It's got to scale up to a much larger production data sets without any degradation in accuracy, and that's important. If the volume of the data impacts the accuracy of the model, then we've got to account for that. And it's got to run in an acceptable manner as far as time or resource usage. It can't be a model that takes all day to run because it's so resource intensive. Some of the more common tools for building the models. We used a small set of tools for model planning, but now we're going to be using large tools, and there's tons of large tools out there. Our SAS and SQL Access are sufficient for planning, and they could be sufficient for your model as well. R is pretty robust, and so it could work fine. But there are also commercially available packages that might be better choices. Things like SAS Enterprise Miner, SPSS Modeler, MATLAB, Alpine Miner, Statistica, and Mathematica are all commercially available packages that you could use, that you can implement to apply your model. Or there's free and open source. We've already looked at R. There's Octave, Weka, Python, and SQL. Many of these are, well, at least 3 of them are programming languages that you would need to write code for to implement your model, and that may be the easiest way to go. Again, it all depends on what the resource requirements are. Each one of these requires varying levels of user knowledge, so it also can come down to what is your team or what are you most familiar with when it comes to thinking about these different resources. Model building is going to be an iterative process. So you can build the model, you can run it in the sandbox, check the results, and revise it and repeat it. When you build your model and you run it, you're going to get results, and those results are going to be very interesting, or hopefully very interesting. Hopefully, by the time you get to the point where you're building your model, you've tested it out enough in the planning phase that you kind of have a good idea of what you're going to get. But the results you get may change based on the volume of data or based on the sources of data. And so that may lead to, and oftentimes leads to, okay, that's really great information, but I really would like to know this now, or I'd like to learn about this, or what about this variable, or what about that? And that gets you to this iterative cycle where you go through and you find stuff and it just suggests more stuff that you want to find, or it just brings up more questions that the stakeholder wants to have answered. So you may go back this whole process and revise and repeat. You're going to test the model to make sure that first of all, that it works, that it provides what the stakeholder needs, that it can be explained, that it can be adjusted and revised as soon as the stakeholder sees the results and wants more information, that it can be replicated in case it needs to be applied in more than one instance, and that it's not going to do any unexpected damage. When all that is met, you have a usable model that's ready for deployment. And that's what we'll talk about next. Next week, actually, we'll talk about communicating results, and then we'll talk about operationalizing those results.